Now just a brief reminder here on finding the zeros of a function. This is actually something we've already done, right? The zeros of a function are the x-intercepts. So when we write an equation in intercept form, the zeros will be p and q. So let's look at this one example. We have f of x equals negative 2x squared minus 10x minus 12. So if we factor here, we can first factor out a negative 2. That will leave us with x squared plus 5x plus 6. And then we can factor x squared plus 5x plus 6. So again, here needs to multiply to 6 and add to 5. So now that's going to be 2 and 3. So that gives me negative 2 times x plus 2, x plus 3. Okay, now again, I have this written in intercept form. That would be a times x minus p, x minus q. And again, since these are both positive, that means p would be negative 2 and q would be negative 3. So my zeros are x equals negative 2, x equals negative 3. All right, now let's look at this next example, graphing using zeros. So we want to graph h of x equals x squared minus 2x minus 3. So this is currently written in standard form. And if you remember, standard form, ax squared plus bx plus c, that c value is always our y-intercept. So we know that our y-intercept here is going to be 0, negative 3. And we could go ahead and graph that. So we have our y-intercept. And now if we factor our function, we can write it in intercept form to get our x-intercepts. So we have x squared minus 2x minus 3. So with that diamond, again, we would need to have something that multiplies to negative 3 and that adds to negative 2. So in this case, that's going to be negative 3 and positive 1. So now we know in factored form, we would have h of x equals x minus 3, x plus 1. So we have x minus p, so our p value is 3, so we have an intercept at 3, 0, and x minus q, so our q value is negative 1. So we have intercepts at negative 1, 0, and at 3, 0. So now that we have 3 points, we can go ahead and graph our parabola here. Just making sure we notice that this y-intercept is not our vertex. It's not the best of parabolas, but we get at least an approximation of what it would look like. Now, we're also going to look at writing functions based on some given conditions. So we want to write this quadratic function in standard form based on the given information. So for example, if we look at this first one, it says a point that has a vertex, or sorry, a graph that has a vertex of negative 3, 4. Now we know that if we write something in vertex form, h will represent our x value of the vertex, and k will represent the y value. So if we write it in vertex form, f of x equals a times x minus h squared plus k, then we could write this as a times x plus 3 squared plus 4. Now, remember that a just causes a vertical stretch or shrink. It's not going to change where the vertex is of our graph, right? We might have something that looks more like this or something that looks more like this, but they're sharing that vertex. So for ease of calculation here, we're just going to choose a equals 1 because we want to write this in standard form. So that's going to make it easier for us to do. So now we just need to write this in standard form. So we have x plus 3 squared, which would be x plus 3 times x plus 3. And then we're adding 4. So let's start by multiplying x plus 3 times x plus 3. We get x squared plus 3x plus 9. So that's x squared plus 6x plus 9. And then we're also adding 4. So that would give us x squared plus 6x plus 13. And this would be our function in standard form that has a vertex of -3, 4. Let's look at this last one here. We want one that passes through -9, 0, -2, 0, and -4, 20. So remember that these first two are our x-intercepts. Those are the zeros of our function. And so we can start by writing an intercept form. So remember, intercept form will be f of x equals a times x minus p, x minus q. So if we have p is -9, then that would be x plus 9. And q is -2, that would be x plus 2. So now we have this other point here, -4, 20. Right? So remember that -4, 20, that's an ordered pair telling me that when x is -4, y, or f of x, is 20. So I can go ahead and substitute here. 20 equals a times -4 plus 9 and -4 plus 2. This will allow me to solve for a. So then I know that 20 is equal to a times 5 times -2. So 20 will be equal to a times -10, and I divide both sides by -10. So -2 will be equal to a. So now I can write this function as f of x equals -2 times x plus 9, x plus 2. And the last step would be to multiply this out so that I can write this in standard form. So we'll start with x plus 9 times x plus 2. That's x squared plus 9x plus 2x plus 18. So that's going to be x squared plus 11x plus 18. So then each of those terms will be multiplied by -2, giving us -2x squared minus 22x minus 36. And that would be our function.